Number 35, the absolute value. Well, basically what we did was plugged in enough points to the left and to the right. And if you plug in -2, -1, 0, 1, and 2, those are pretty much 5 standard x values. When you plug them in, you get these y values. But as you notice, this only makes a straight line. This is an absolute value, and an absolute value goes makes a little V-shaped. Well, I haven't hit this part yet, so I ended up going 3, 4, and 5. And if you notice, when I plugged in a 3 to the absolute value, 0 came out for the y value. So basically, what I did was the absolute value of 3 minus 3, which is absolute value of 0, which is 0. So when I started on the other side with the 4 and the 5, when I plugged in the 4, I got a 1, and then a 5, I got a 2. So basically, if you notice, it does exactly what I just told you. It made this V shape. And remember, just like a quadratic, the axis of symmetry cuts right through the vertex. Now, your vertex happens to be where it goes in different directions. So that's at -3, 0. And the axis of symmetry goes right through that. And it's a vertical line, so it's always going to be an x equals. And this happens to be the x value of the vertex, which is 3, so x equals 3. The domain, just like we did earlier in one of the pictures with the domain and range, we look at the least value and the highest value. So if you notice, this is going forever and ever this way and forever and ever this way. Therefore, your domain is going to touch all real numbers. It goes from left to right forever and ever and ever. On the range, the lowest value is right here. And so the lowest value is, the y is 0. Well, because they're both going up forever and ever, that means it's going to go to infinity. Therefore, you have a couple of ways you could actually write this. You could say that y is greater than 0, so that means it starts at 0 and goes up forever. Or you can say that that your range, let me erase this, you can actually do it in set notation, so you can actually go from 0 to infinity. We're going to put this right here, and let's make this a bracket. Alright? Now, number 36, basically this is very much like one I had done earlier. You find the rate, which this happens to be 15.2 divided by 8, and this is 3.8 divided by 2. They both came out to a rate of 1.9, which means they have the same slope, so it's linear. Now, what I did was I created the first part of the equation. Now I have to go find the 3. Well, you know that when x is 0, we'll get our y-intercept. So if you go this way, if you do 7 minus 0 and put that on the bottom here, and you do 16 minus 30 and put that on the top, you get your rate of change in y over change in x. And you know it's got to equal the same as these other two at 1.9. Well, what you end up getting is this. You basically solve an equation, 16.30 minus y over 7 is equal to 1.9, and you end up solving for y, and it turns out that y is equal to 3. You then plug that back into this equation, and that, therefore, there is your equation that you're going to be using. Now, we're not done yet. What we want to know really is when x is 24. So we plug in x in for 24 in for x, and we get $48.60 is our y value. On number 37, you could have just plugged in 12 like I did right here and found out that y would be 360 miles in 12 hours. Or you could build this graph, and it's a rise of 30 over 1, 30 over 1, 30 over 1. That's the rate, all the way up till you get to 12 hours. And notice on the graph, at 12 hours, it's going to be 360 miles. On number 38, there's a couple of ways you could have done this. I'm going to show you one method. I distributed the -7. I got -7z plus 14 is less than or equal to -7z plus 7. I then added the 7z to both sides, and it's okay that these two canceled out, because what was left was 14 is less than 7, and that is not true. So since it's never true, it is therefore no solutions. And then finally, the last two problems, if you write 14 letters each month, the way you're going to write that is an expression of 14x. Now, 2x minus y equals negative 11, and basically x minus y equals 2. I want to eliminate the y values, so therefore I multiplied the bottom equation by negative 1. And in doing so, I didn't do anything to the top equation, I just wrote it as is. The x becomes negative, the y becomes positive, and the 2 becomes negative over here. I've simply added straight down. 2x minus x gives me 1x. The y's cancel out. And negative 11 plus a negative 2 is a negative 13. So there's x. I then plug in that x right here back into this equation. I add 13 to both sides, divide by negative 1 because I want to get rid of that negative 1 right there, and y is equal to negative 15, giving me an end result of a coordinate point of negative 13, negative 15.